So our measurements in chemistry are often really big or really small. That's because atoms are really, really small and there's a lot of them in our samples of matter, so our numbers will be really, really big. So to make this easier on us, we often use numbers that are in scientific notation. This number in scientific notation is a coefficient raised to a power of 10. The coefficient, which is the number in front, has to be greater than 1 but less than 10. For example, 1.3 times 10 to the 7. So our coefficient is 1.3 and the power of 10 is 10 raised to the 7th. Okay, this really means 1.3 times 10 times 10 times 10 times 10 times 10, you get the idea, times 10 7 times. If I punch that in my calculator, 1.3, and then times that by 10 7 times, I get an answer of 13 million. So I could use numbers like 13 million, or I could make my life a little easier and shorten it down to 1.3 times 10 to the 7. Now 13 million may not seem like that big of a number to you, but our numbers, our coefficients, our exponents can get a lot bigger than 7. So scientific notation becomes a necessity at that point. So if I have a number that's greater than 10, the exponent equals the number of places the original decimal point has been moved to the left to write the number in scientific notation. So here's our example here. 1.3 times 10 to the 7 is 13 million, okay, with a decimal point at the end of that last zero. But if I move that decimal point 1, 2, 3, 4, 5, 6, 7 places to the left, I get that coefficient of 1.3 again. 1.3 times 10 to the 7. Those two numbers are the same. For our next example, I have 3.6 times 10 to the 4. If I have the 3.6, and I just move that decimal point, this time to the right, 1, 2, 3, 4 places, I get 36,000, which is the same as 3.6. So you try this one. Let's take the number 240,000 and turn that into scientific notation. Did you get 2.4 times 10 to the 5? So all you have to do is move the decimal point, which would be here, 5 places to the left. 1, 2, 3, 4, 5 to get 2.4. 2.4 is a number that is bigger than 1 but less than 10. So I know I'm done. And I moved it 5 places to the left. That's why my exponent is 10 to the 5. Okay, if you have a number that's less than 10, the exponent equals the number of places the original decimal point has been moved to the right to write the number in scientific notation. So here I have 8.1 times 10 to the negative 3. So that really means 8.1 divided by 10 times 10 times 10. If I punch that in the calculator, I would get 0.0081. Or I could just move that decimal point to the left 3 places to get 8.1 times 10 to the negative 3. Okay. So let's try this next one. 7.5 times 10 to the negative 5. So that exponent, negative 5, equals the number of places the original decimal point has been moved to the right. Okay, so let's move it back to the left to turn it into its decimal notation. So I'm going to move it to the left 5 places. 1, 2, 3, 4, 5. Okay, so that number is equal to 0.000075. All right, you try this one. Let's take this number and write it in scientific notation. So here we are with the number, and all you have to do is move it to the right to get a number that's bigger than 1 but less than 10. And count the number of places you moved it, and that is your exponent. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now I have a number that's a coefficient that is bigger than 1. 3.27 is bigger than 1, but it's still less than 10. But my exponent is times 10 to the negative 12. This is a really small number. Our original number, point a bunch of zeros, 327, is a number that's less than 1. So it's a really small number. So it's going to have a negative exponent. Okay, so scientific notation makes it easier to handle extremely large or extremely small measurements. The numbers expressed in scientific notation are a product of two factors, the number between 1 and 10 raised to some power. If your number is greater than 10, the exponent is the number of places the decimal point has been moved to the left, and large numbers, bigger than 1, have positive exponents. If your number is less than 10, the exponent is the number of places the decimal point has been moved to the right, and small numbers always have negative exponents. In the next videos, we're going to talk about how we do math with numbers in scientific notation, but you have to have an understanding of how to turn a number into scientific notation or take a number that's in scientific notation and turn it into a decimal before we do that. If you have any questions, please let me know.